Okay, so this is part 2 of the background of blood pressure. Okay, so there are 3 things that affect blood pressure: heart rate, stroke volume, and systemic vascular resistance. Let's go through each of these. Heart rate, abbreviated HR, is how fast the heart is beating. Stroke volume, abbreviated SV, is how hard the heart is beating. I'm kind of lying to you here because stroke volume is how much blood the heart is kicking out, but that's directly correlated with how hard the heart is beating. Okay, so there's a difference between how fast the heart is beating and how hard it's beating. The third one is called systemic vascular resistance, or SVR. This is resistance against blood flow to the skin. Okay, it's a little complicated, so let's go through this one. Okay, if you have high resistance to blood flow to the skin, that means that the blood vessels are constricted in the skin, which means they're vasoconstricted. They're vasoconstricted because we have targeted alpha-1 receptors that are embedded in the smooth muscle surrounding the peripheral blood vessels, and they're going to shunt blood to the core, and the patient's going to look pale. Okay. Conversely, if we have low systemic vascular resistance, that means the blood vessels are wide. That means they're vasodilated. That means we are blocking alpha-1 receptors in the skin. That means that the patient's going to look flushed because we're actually shunting blood away from the core and to the skin. Okay? So, if we take these 3 factors, heart rate, stroke volume, and systemic vascular resistance, we multiply heart rate by stroke volume by systemic vascular resistance, you're going to get blood pressure. And here's the set point that we generally go with, 120/80. Okay. So again, heart rate is how fast, stroke volume is how strong. Resistance, you have 2 choices. Resistance is high if they're peripherally vasoconstricted, or resistance is low if they're peripherally vasodilated. As a side note, if you take heart rate and multiply it by stroke volume, that is what we call cardiac output. Okay, so now let's look at the immediate effects of something. So let's say you get scared. A car backfires or something right next to you. There's a very loud noise, and it's like a jump scare. Okay, immediately your heart rate is going to jump up, because heart rate times stroke volume times resistance is equal to blood pressure. That means that your heart rate is directly proportional to your blood pressure. So if your heart rate jumps up, your blood pressure temporarily will spike. Okay? Same thing. If your stroke volume jumps up, so will your blood pressure. If your resistance spikes, so will your blood pressure immediately. Same happens if it drops. Okay? If you experience what's called vasovagal response. Vasovagal response is when your heart rate drops. It goes right into the basement. Okay, well, if that drops, that means your blood pressure drops, because they're all directly proportional to blood pressure. Okay, now let's figure out what happens when we compensate for that change in blood pressure, because we want to stay at that set point of 120/80. So let's say you have a patient who's hit by a car, and they have an open femur fracture, and they've pumped out 2 liters of blood onto the highway. Okay, so that means that there's not a whole lot of blood for them to pump around. So their stroke volume is going to be very, very low right away, which means their blood pressure is going to be very, very low right away. But fortunately, within seconds, the body's going to compensate by jacking up the heart rate and jacking up the resistance, which in turn will jack up the blood pressure back to normal. So you're going to have a very, very, very high heart rate. You can't do anything about stroke volume because there are 2 liters of blood laying on the highway, so we can't fix that just yet, okay? But we're going to have a very, very high heart rate, and we're going to have a very high resistance, which means that the patient is peripherally vasoconstricted, which means the patient is pale. However, their blood pressure appears normal.